Okay, so we're going to go ahead and finish this continuity and one-sided limits. And so if you look here on the board, what you notice in these two blue boxes, you should notice something that's different from everything else we've dealt with this chapter. Okay? And if you notice, it's these little, the plus and the minus. And so up here, what we're going to do is we're going to think about what does that plus and minus mean, and what do you think it's going to do to the meaning of a limit? So what do you think that plus and that minus means?
It's going to all be positive. That's all back on the right side.
I want you to think about a number line.
Right side.
Ah, what'd you just say? Say it louder.
All be on the right side.
The right side. So when you see that little plus there, what that means is that means the limit as x approaches c from the right. Okay, so the limit as x approaches c from the positive side, which is the right side. Oh, let's try that one again. That was a bad R. There we go. All right, what do you think the negative means? Yep, the limit as x approaches c from the right or from the left side. Okay. From the left. And so these are one-sided limits. And so if you think back to our original definition of a limit, what did we know about the limit on the left and the right? They had to equal each other if it was the limit at the total answer. In this case, we're just looking at one side or the other. So they might not match, and that's okay. So what we're going to do is we're going to look at a few graphs of these. And so if you look at this, okay, the limit as x approaches -2 from the right side of square root of 4 minus x squared. And so when you graph that, looks like that. Okay, and so what's going to happen is I'm here at -2, that's where I'm looking. And so what I'm going to do is at -2, I'm going to look from the right side. So here's -2. Notice there's nothing to the left, so obviously that's the only reason or one of the reasons why we're looking from the right side only. So what y value does it look like I'm going to hit as I travel along that graph? 0. There you go. That's your limit. That's it.
Make what?
Okay, the limit, -2 from the right side is going to be 0. Yep, it's approaching 0. Let's look at another one. Now this one's a little different. You're going to have to locate this one. It's located under Math, Num, and you're looking for INT. And then just X. Math, Num, INT.
Wow, holy genius.
Okay, so what ends up happening, what the graph looks like that, okay? So let's look at the first one. The limit as x approaches 0 from what side? The left. So here's the left side, right, of 0. And so here I am on my graph. What y value does it look like I'm approaching as I move towards 0? 1. Now this next one says 0 from the positive side, so 0 from the right. So here's my x values on the right. So I'm going to go here. What y value does it look like I'm approaching? 0. Okay, so this is an instance of where if we wanted the limit as x approaches 0, just 0, not anything with it, of the greatest integer less than or equal to x, this would be DNE, because the limit from the left does not equal the limit from the right. So essentially, we've already been doing this, We just haven't put terminology to it because what you've done on the graph is, remember, this is what you would do. You would write 0 on the graph usually when we went through and did this in class, and then this would be like -1. So you've essentially done this. You just haven't like written it down in this form. Alrighty, the last thing we're going to talk about is the intermediate value theorem today. The intermediate value theorem says if f is continuous on the closed interval a, b, and k is any number between f of a and f of b, then there is at least one number c in a, b such that f of c equals k. Okay, whoa, what exactly does that mean? Okay, so let's figure out what that means. Now, just hold on. I'm gonna do kind of an illustration of what that means. Okay, what that's saying is that if f is continuous on the interval a, b, so here's a, here's b. If it's continuous, I know that the graph has no breaks. So I know that I've got this point, and let's just say this point up here. And the graph, let's just say, goes like that. And so here we go, here's f of a, or actually f of b, and then this is f of a. Which, if you remember, f just means like your y values. So when it says f of a, that means the y value at a, the y value at b. It says, and k is any number between those two values. So I'm going to pick any value here. So I could pick this value, this value, this value, and all those values could be k. What it states is that if this graph is continuous, there has to be at least one number that's on that graph. And we call that one C. Yeah, I know, it's one of those, well, yeah, that makes sense. Okay? Okay. So if you notice, that's all it's saying, is that if K falls between these two values, there has to be C somewhere between A and B. It's on the graph. Okay? So then now with that in mind, let's go ahead and look at where we're going to use that in this problem. It says use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 in the interval 0, 1. Okay. This is going to take us a lot longer to write down than it actually is to solve. Okay, here are my x values. So in my problem, what am I going to use? I need my y values. So I'm going to find f of 0 and f of 1. What is f of 0 going to be? Negative 1. What is f of 1? 2. So what this states is it says show that the polynomial function has a 0. Well, let's look at these values. There's got to be a 0 between that if it's continuous. There's no way that you can miss 0. You can't avoid crossing the line. I mean, if you plot those points, like, undo dummy. Okay, here we go, right here. Negative 1, and then f of 1 equals 2. There's no way you can connect those dots between 0 and 1 without crossing the x-axis. So all we have to do is state that. And so what we're going to do is and so you're going to have to write something here, okay? I know you love writing things. Okay, 0 falls between negative 1 and 2. Okay. There is I knew that was going to happen. 0 in the interval 0, 1. Okay? So that's the end of section 1.4. Now real quick, let's go back here. I need to add something, so I don't think I put any intermediate value theorems on there. So you have 78 through 80.
Wow, you want to kill us or something? Jeez.
Was that like the same thing when you did 42?
And then I want you to do 75 and 76. Okay?
Is this a continuation of the last one?
Yes.
So change 1 to 6 to 1 to 12.
Yes, 1 to 12, 25, 26, 69 through 72, and 75, 76. Okay, we only have one section left in this chapter. Okay, so